Awesome. Okay, so today we'll be doing a very fun topic. Games. Who doesn't like games? Am I right? So this doesn't really have a set that as something like a theory that you need to learn or know. But there are a few techniques that are usually used, which I would like to highlight. Let's get right into it. So one thing, okay, let's start with an easy game. Game one. Uh, all right. So okay, let me describe the types of games that we will be seeing. So they're going to be okay. Usually, most of the times it's two-player games. I think throughout today we will be looking at two-player games. What does that mean? That means there are two players, and they move alternately. So let's say we have usually they're just named Alice and Bob, uh, because A and B, but we can be slightly we can say Moksha and Nishkarsh, so it's M and N because we don't want to. Yes, because why not? These are going to be the two players that we're going to call these to be the two players. Moksh always likes to go first. Nishkarsh goes second. That's going to be the convention. Also, a few more things. The players play alternately, and it's a perfect information game, which means that whatever it is, like both the players know everything about whatever is going on. For example, what would not be a perfect information game is like if I give five cards to Moksha and Nishkarsh. So Moksha doesn't know what cards Nishkarsh has, and Nishkarsh doesn't know what cards Moksha has. So that's not a type of the game that we'll be looking at. Why? Because we want to only okay for now we only want to study games that don't involve any randomness and probability. We want deterministic games, so that's why. Although if you're interested, you can look into some probabilistic games later. Yes, so everybody knows everything. And what else? Okay, so there's a no luck based exactly. So so now there's a theorem which states that if you have such a type of a game where everybody knows everything and there's no randomness, then there is always a strategy, which means either player M or like either M will always win, which means the player who goes first always has a winning strategy, or player N has a winning strategy, or both of them have a strategy by which Zermalo theorem, by which they can make the game to be a tie. So neither of them win. So we will look into some more examples, but yeah, it's very cool. And what do I mean by a winning strategy? Means a strategy is a winning strategy for player M. If no matter what the other player does, you will win. No matter what the other player does. That's what I call a winning strategy. Okay. Awesome. People, don't put things in the chat. Just unmute and discuss whatever, because it's hard to keep track of the chat and also talk. Um. Anyways, okay. Let's start with a slightly easy question. Let's say there are. Oh yeah, raise hand. Raise hand. Yes, Debarchan.
How hard is it to prove Zermalo's theorem?
That's a good question. I think it does require some. Maybe we can.
When inducting the depth of the tree, which is formed by the positions of the game.
Interesting. Maybe we can have another. Yeah, maybe we can have another session on it for interested people. I think that'd be a fun class. Yeah, but that's basically the idea. Okay. Yeah. Okay. So here's game number one. It's again M and N are playing. M goes first, and let's say you have 50s. Okay, what's today's date? 21. We have 21 stones on the table, and at each step, so for both M and N, you are either allowed to take away 1 stone or 2 stones. So on your turn, you can take away either 1 or 2 stones. And player who, so there's another criteria, which is when do you win, when do you lose. So the player who cannot make a move loses. Lose it. Okay. Is the question clear enough? Maybe we can do one round of quick play. Do I have volunteers to
Wait,
play?
who goes first?
M goes first. Oh, okay. Who goes first? Sure. Would you volunteer to go first?
Yeah, I'll go first.
Okay. Yes, we have the actual Moksha volunteering to be the Moksha. Great. How many stones do you take away?
I'll take away 2 stones.
Okay, so after M did -2. So we have 19. Okay, Sam, you want to Nishkarsh, can you be the actual Nishkarsh and play against Mo?
Yeah, sure. So
Awesome. What will you do? I'm so sorry, your voice is cutting out a lot. Oh, I couldn't make out anything you said.
I could go second.
Sure, Aritra, go ahead.
We can remove 1 stone.
Oh, okay, now we have 18. Moksh, what do you want to do?
I'll remove 1 stone.
Okay. What do you want to do, Aritra?
I can remove 2 stone.
hello, can you hear me?
Yes, Nishkarsh is back. So Nishkarsh, Aritra played for you while you were gone. You can continue from here if you want to. Okay, it's Moksh again. Moksh, what do you want to do now?
I'll remove 1 stone again.
Awesome. Okay, Nishkarsh, what do you want to do now? Is Nishkarsh gone again? Oh no, Nishkarsh is gone again. Okay, Aritra, you can continue.
I can remove 2 stone.
Okay, so we have 12. Then,
Then I remove 2 stones.
awesome.
Then I remove 1 stone.
Okay.
Then I remove 1 stone.
Okay, fair enough. Now,
I can remove 2 stone.
uh-huh.
Then I again remove 1 stone.
Nice.
Then I do 2 stone.
Okay. Oh no, what is this?
Then I remove 2 stones. One is left.
Sad.
And I remove and I can remove 1 stone.
Sad. Okay, so this was winning for N. Interesting. Okay, here's an observation. So the moment you reach 3, you know that you're going to win. Like, okay, so let me try to rephrase this. If there were 3 stones initially, then no matter what M does, okay, no matter what Moksha does, Nishkarsh is going to win. So if stones is initially 3, then winning for N always. Do people see this? Well, there's nothing you can do. Like if the first player removes 1, then you can just remove 2. If the first player removes 2, you can just remove 1 and win. Uh-huh. Can we extend this logic?
You can make it
Then
6
4
and
and 5
9.
are
Yes. 4 and 5 are?
winning for M.
Okay, how?
Because from 4 and 5 we can convert it to 3, and then since 3 is the winning position for the
Exactly.
second one, which is M, so it wins.
Exactly. Exactly. Because we can reduce this to stones is equal to 3 case. And when we remove something and reduce it to the stones is equal to 3 case, the first turn now goes to Nishkarsh, which means we are the second player now. Or originally the person who was the first player is now going to go second. So, and we know that 3 is winning for the second. So 4 and 5 are winning for him. And now Athara was saying something.
You then 6 is a winning position for N, and then similarly
Exactly.
7 and 8 is for M, and then you go to all multiples of 3 is for N.
Exactly. So 6 is winning for N because no matter what the first player does, the first player cannot reach 3. So if you can, so they'll either go to 4 or 5, and then we can use this strategy. And we can continue doing this. So 7, 8 will be winning for M, then 9 will be winning for N, and so on. So on and so forth. So again, an observation that was made that multiples of 3 is a winning case for the second player. And otherwise, the first player has a winning status. Okay, does this make sense to everyone?
Yes.
Awesome.
Yes.
Okay. Okay, so now there are multiple variations of this that we can look into. Maybe this I'll put them up in the problem set. So, what variations can we look at? Maybe we'll look at a few. We'll discuss a few, or we can just list down a few and I'll put them in the problem set. You guys volunteer some nice variations. Maybe I'll start off with one. Yeah, Moksha, go on.
Basically, the game TDS and two people. That's a variation of this.
Wait, say that again.
21 days, but with only two people playing.
This was only 2 people, right? Wait, I didn't get what you want to say.
Basically, 21 days, the game. Like,
No.
it's basically like the first person to say 21 loses, so they have to do a dare. So that is a variation of this. We
Oh,
can
so
only do
the
1, 2, 3 of
okay,
1 or 2 or 3. Plus, like we can add 1, 2, or 3 in the numbers, like the existing,
okay,
and the first person to say 21 loses. So that's how the game is played.
okay, interesting. So this is where you can add 1, 2, or 3 in a turn, and person 21 loses. Interesting. What are the quantities that can change it? Quantity we can change is definitely instead of having a +1, +2, we can change it to you can add any number from 1 to n. So one thing you can change is add any number from 1 to n. You can change the winning condition. Let's say the person who cannot make a move wins or something like that. Or we can make this slightly even more harder by saying something like instead of adding any number from 1 to n, we can try to make it you're given some particular set of natural numbers and you can only choose numbers from that set instead of 1 to n. That's one variation that we can look into. A some set of natural numbers and can only subtract number from A. That could be one thing. Or another could be that both of the players had different sets to choose from. And so on and so forth. And both players have different sets to choose from. Okay, are people able to think of any more variations?
We are going to solve these variations.
No, not right now. I'm just listing them down for fun so I can make you guys solve it later for homework or like P-set or something. Okay, did people get quiet because I said I would make you guys do it? Okay. Okay. We'll keep this list open. If later on during the session, if you think of something, we can come back and add things to it. Okay. Here's another cool
Maybe you could
problem that
play
I really
on
like, which
two
has a similar.
numbers.
Yeah.
Maybe you could play on two numbers simultaneously. Both players decrease from either one of the numbers, and then the first player to make the first player who makes a turn which both numbers are zero, that person wins.
That's a great idea. Simultaneously. I don't know how to spell it. Did I spell it right? Oh, nice. Okay. We'll definitely be discussing this part in later one. There's this another fun variation that I really like that we can discuss right now. Where again we are given a number, let's say again 21. The catch is the rule number 1. In the first move, you cannot make it 0. However, there's another rule number 2. Let's say although you can take out as many stones as you want in the first move, but in every what's it called, every consequential move, I think that's the right word. In every consequential move, what you're allowed to do is just you keep track of the number of stones you removed in the person removed in the previous move, and you can only remove twice as many stones as that this time. So say X stones were removed by the other player in the previous move. You can only remove up to 2x stones. And again, winning condition is up to player who can't make a move L. And does somebody want to volunteer to play this with? Okay, sorry. I wasn't checking the chat. What have we done so far? We just solved this one question. We have Moksh and Nishkarsh, 2 characters, completely random names. I don't know where I got them from. They're playing a game. We are going to make them play a lot of games, basically, and we want to figure out which one of them has a winning strategy. The first game we played was we are given a pile of 21 stones, and in each player's turn, you can take away either 1 or 2 stones from the pile. Oh yeah, another variation I just thought of. More than 2 players, what happens? Okay. Also, I'm not sure how we could define winning, etc. in this. There's like a lot of question marks here because of that. But okay, that's definitely something to think about. But yeah, that was the first question we solved. Now we are trying this one. Does somebody want to volunteer to do? I need 2 volunteers to play this. Anybody wants to go first?
I'll go first.
Who is this?
Moksh.
Moksh again. Okay. Sure. How many? And who wants to go second?
I can go second.
Aritra. Okay, fine. Yeah, Moksha, how many do you want to remove?
I'll remove 6 stones.
6. 6 have been removed, so now we have 15. And Aritra can only remove up to 12 now.
I will remove 3 stones.
Okay, so now Moksha can remove up till 6.
I'll remove 3 stones only.
3 again. So Aritra, you can now only remove up till 6.
I can remove 2 stones.
Okay.
I'll also remove 2 stones.
What is
I can remove
Aritra's
1
move?
stone.
Okay.
1 stone.
1. Okay.
I'll also remove 1 stone.
Okay.
I have to remove 1 stone.
Okay.
I'll remove 2 stones now.
Yeah, player 1 wins. Okay. Interesting. Do people have any observations from this?
Basically, 4 was the point like after which the winner was decided.
Right. So 4 is winning for which player? If we start with 4, then it's winning for
It's winning for player 2.
player 2. Okay, why don't we do one thing? So, a very good idea for such types of games is just to start from scratch, start from the bottom, and then just list down for which numbers is it winning for which player. I think this is called the P and start steps. Okay, so if there's only one stone in the pile, which player wins?
No one wins.
Second player, because the first player can't take any stones.
Okay, wait, one doesn't make any sense. Sorry, 2. For 2, it's which player?
Player
Second
2.
player, because the first player can't take the entire pile.
Yes, and for 3?
Player 1.
Yes, that's just
Yeah.
remove 1. Okay. How about 5?
If you remove 1, then player 2 can take the whole pile. Each player 2 will
So
win.
sorry, I guess number 3 would be player 2.
Yeah.
Oh yeah, sorry.
Because player 2 can take 2, right?
Math. Yeah. Yeah, for 5, what was it for 5?
Player 1, because player 1 can remove 1 stone, and then player 2, and then just repeats the previous cycle.
This makes sense. So you can remove 1 stone and the player 2 can remove at most 2. So can't really do much. Okay. How about 6? Quick.
Player 1.
What will your strategy be? How many will you remove?
2.
Then I can remove
I
4.
guess
If you remove 2, I can just remove 4, right?
I can remove 1.
You can
Then
remove
we have
1.
5. And then player 1 wins. So player 2 is winning, I think, in 6th.
Yeah, if you remove 1, even I will remove 1 because that's the strategy for 5. Does that make sense? Okay. 7?
1 minute. Like, why does player 2 win when there are 4 stones in the pile?
Oh, what will your strategy be? Let's say you are player 1 and we start with 4.
I just
How much
take
will you remove?
1 stone.
You remove 1 stone. Yes, so now we have 3 remaining. Oh yeah,
So-
true.
Yeah, it can be 2 or this one. So wouldn't player 1 win in that case?
Yes, I don't know. I don't know. I'm just writing what you guys are telling me. Okay. Okay, now what do we do? For player 6, I think it's still player 1 is winning, right? Or is it?
It's player 2 only. Is 6.
Oh, so is this right then? This is
Yeah,
not
I
right
think
then,
No,
right?
it's not right.
Yeah,
I
so now this is player 2. Okay. So now for players, so for 6, now it should be 1, I guess. Right? I don't know. I'll wait for you guys to tell me. So if we, yes, can somebody like unmute and loud thing?
Yeah, it's
Yeah.
player 1 because player 1 removes the first stone and then they become player 2 essentially. And they have a strategy for 5.
Yes. Okay. 7.
7 also player 1 wins
player
because
1
he
we can
can
remove
remove
2.
the 2 stones.
Awesome. Okay, let's try to make this a little faster. Player 8. Sorry, 8.
8 is player 2.
Player 2? Paka.
Yeah.
Okay. Okay, somebody quickly who's not moves, just like quickly just give like a 1 or 2 line description
Oh.
for why 8 is player 2.
Player
Player
1 should win because he can remove 3 stones, and
If we remove
player
3
1
stones,
removes 3
player
stones,
2
then
can just
player
remove
2 will remove 3.
5 stones, right?
Ah.
The whole pile would be gone.
Yeah. So if we remove 3 stones from 8, we'll have 5 remaining and we can just take, the player 2 can just take all of it.
okay, I understand.
Okay.
Player 1 can remove 1 stone and win
Yeah.
for 8.
I just write -1. Okay. How about 10?
10 also player 1, we can remove 2 stones.
Okay. How about 11?
Player
We
1
can remove 3
removes 3
stones
stones.
in 11. It's winning for player 1.
Okay. How about 12?
Player 2. Because if they
It's player
remove 4 stones, then player 2 will take the whole pile. And if they remove 1 to 3 stones, it's essentially the same as player 2 playing as player 1.
Player 2? Are you sure though? Like, I don't think so. Wait. If you remove. Hmm.
If player 1 removes 4 stones, then player 2 just takes the whole pile. And if they remove 1 to 3 stones, then player 2 uses the strategy for player 1.
Okay. How about 13?
Player 1 wins. He can just remove 1 stone.
Okay. Is there a pattern you guys are seeing?
It's like player 2 is coming once, then like first it was 1 player 1, then 2 times player 1, then 3 times player 1, then 4 times player 1 will be coming.
Something triangular numbers.
I think 12, I think still player 1 as a strategy, guys. I want you to think a little bit more for 12. See, 11 was a strategy for player 1 to remove 3
You have player 1 removes 4 will go to 8. So then player 2.
For 12 stones, we can't remove 4 stones because then the whole pile would be taken in the move.
Yeah, no,
We remove
no,
1, 2, or
what?
3.
Okay. Uh, Okay, let's do this. Let's do this, guys. Let's 12. And I'm the first player. I will win. I will guarantee. See, if I win this, you guys have to give me something like a chocolate or something.
We need to remember all the strategy before that. So you might end up winning because of that.
No. It's okay. Like, okay. So, are you completely sure that 12 is going to be winning for player 2?
Yes.
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 Okay, so
Don't
if
worry.
I win this, I need something from you guys. I need you to send us in the chat. If Saee wins this, I will give her something. Okay, let's do this. I will remove 1. So now we are at 11. What will you guys do?
I'll remove 3
Minus
stones.
3.
You can't remove 3. I removed 1. You can only remove up to 2. I am so evil.
I get your strategy.
Do you get my strategy though?
We can remove 2 stones, then also.
Wait, then
then
means
we
what?
lose.
Wait, because if we remove 2 stones, then
That's how.
so we also need to keep track of which has a winning strategy based on how much you remove in the beginning. It just
Exactly.
backwards inducting isn't this.
Everybody's going to give me a chocolate. Ha ha. Okay. बैठ हार गए. L. Okay. So, do people see this? Do people see the evilness? No, sorry. Do people see how we win for 12? How player 1 wins for 12? I don't know. I don't know when you guys give. You have to meet me now. Switch on your cameras. That will be a big enough gift for me. Okay. Oh, thank you, Mook. Okay. Anyways, let's not get distracted. Who's gonna win for 13? You guys have to think before saying this time. I think I will put my on charge and be.
Player 2, I guess.
How sure are you? Would you give me a chocolate or not? Do
Pretty
people
sure.
agree? Yeah. Do people agree? What's the vibe here, guys? Are people agreeing with Devarshan? Sorry, Devarshan, or something in the chat. Agree. We must do now. I know this is right. This looks right. Good job, guys. How about 14?
Player 1.
Wow, did I
Just
scare people off? Okay. Okay. I didn't scare people off. That's good to know. Fair one. I was for people who are scared of me now. Yeah. For people who are scared of me now, don't be scared. I was just joking, okay? Ha ha ha. Or was I? Anyways. 15. Who is winning? Who's winning for 15? I think like some people might have picked up on the pattern already. Maybe. Have people picked on the pattern? Okay. Do people want to be bold and make a conjecture at this point?
Wait,
Oh, it's coming in
Oh.
powers of 2 something.
yeah, so we
1,
can try
3, 4,
considering it
then
binary. Like we can try seeing which numbers have a winning strategy for 1 in binary or something like that.
Binary. Okay. Like binary is definitely an excellent strategy, but over here in like we have 2, 3, 5, 8, 13 guys so far. I'm just listing down the numbers which are winning for player 2. Exactly. Yes, Fibonacci. Very cool. And to display more of my evilness, I shall leave you guys hanging and we shall move on to some other problem. Do I like dark chocolate? Not. I don't like chocolate in particular. I like chocolate when it's in other things like chocolate cake or chocolate shake or something. Anyways, we're not talking about that. I shall leave you guys hanging on this. Oh, so evil. Atharva will give me dark chocolate. That is just pure evil of you, Atharva. Anyways, okay. Let's move on. You guys, maybe I'll put this problem in the preset and ask you guys to prove this or something. Okay, we will move a little back and go back to Atharva's wonderful problem having two numbers simultaneously. So let's say we have two piles of stones instead of one. Let's say it's like 21/7. The date today is 21/7, so we make it 21 in the first pile, 7 in the second. Yeah. The problem is I'm discussing it right now. We're starting a new problem right now. Aditya. Okay. And in each move, you can take as many stones as you want. The thing is, only from one pile. Only from one pile. Any pile of your choice. Which player has a winning strategy? Wait, I can't spell. Yeah.
Is the winner the person who takes the last?
Amazing.
Player
I
1.
forgot to mention that.
Is the
Player
winner
who
the person who
cannot
takes the last?
make a move. Yeah, what did you say? Okay. Yeah. So I think we have some nice strategies already. So what would the strategy be?
Removing 14 stones from the first pile would be a winning strategy for player one.
Okay. So now there are 7 and what is this pen? Then there will be 7 and 7. Now what do we do? Now what does player
Now
2
we
want to
just
do? Does somebody
copy
want to
the
volunteer as player 2?
done by player 2.
Hang on a second. Can you guys carry? Am I audible?
Yes.
Yes.
Wrong answer. I am Saee. What? Okay. Yes. So 7 and 7. Now, what is the strategy after this?
Just copying the move that player 2 does on the other pile.
Exactly. So this is like a very symmetric situation. So whatever player 2 does, let's say they remove 2 from this and make this 5. We can also remove 2 from this and make it 5. So as long as player 2 has a move to make, we also have a move to make. So there's no way we are losing unless player 2 loses, but then if player 2 has lost, then they've just lost and we won. Amazing. Are people okay with this? Okay, so remove 14 from 21 to make it 7, 7. And now copy whatever player 2, 3. Yeah, player 2 does. Okay. So what are the winning scenarios for player 1 over here and what are the losing scenarios? So for which A comma B does player 1 win?
When A is not equal to B.
When A and B are distinct, yes. And otherwise, so if and A comma A, player 2 wins. Yeah. Okay, is this okay with anybody? And does anybody have any questions about this? Amazing. So, this strategy is actually used a lot. The idea of symmetry and the idea of copying what the other player is doing. So let's take another example, another classic example. There is a rectangular, there's a square board. There is a square board and both players, okay, on your turn, you can place a coin anywhere on the board so that it doesn't overlap with a previously placed coin. And all the coins are identical. Find out, okay, would you rather be M or N?
And you place a coin in the center.
Exactly. You start as the first player and you place a coin in the center. And what do you do next?
Whatever you do, I rotate it 180 degrees about the center.
Exactly. So whatever the other player does, you just copy it on the other side. And you keep doing this. So place in the center and copy. So idea again, as long as player 2 has a move, so does player 1.
But if the square is like
But
having
what?
an even side, let's say the square is 8 by 8, then there's no center.
Or 2 into
No,
2?
no, you can just, okay, let me tell you. If it's, so there's like these grids are, you're placing them hypothetically. The thing is, the coin, you can just place it over here. You can place it anywhere you want. It doesn't have to be exactly inside the grid or something. You can place it here also. Nobody's stopping you from placing the coin as long as it satisfies these conditions. Fair enough?
Why do you have to actually prove? Why don't I?
Sorry.
What do you
Say
actually
that again.
do in this problem? I don't understand.
So the first player has a winning strategy over here. The first player will place the coin in the middle, and whatever the second player does, you just flip it and rotate it by 180 degrees and play your coin, paste your coin there. So you never, okay, maybe I didn't mention this. Person who cannot
You have to
make
prove
a
in
move
this problem.
loses. So which player has a strategy? That was the question, and the answer is the first player has a strategy, and the strategy is this. Did that makes more sense?
Yes.
Arithya? Okay. Arithra, did that make more sense? Okay, I can't hear you. Let's move on. There's a very cool problem I wanted to talk about. Okay. Okay, people. Sorry, Arithra, your voice is cutting out a lot. I'm not sure if it's an issue at my end or yours. Can people hear me all right?
Yes.
Yeah, I'm here.
Yeah.
I'm hearing you.
Okay. So maybe Arithra, if you have can you put your question in the chat? Because I cannot hear you properly. Okay. In the meanwhile, obviously, since we're talking about games, we have to talk about this amazing game. It's called chess. Okay, so I'll just assume people know what chess is. So it's insanely hard. So no, I do not have a strategy for chess, unfortunately, but we will look at a variation of chess and try to find a strategy for it. So it's insanely hard to come with a strategy for chess, obviously. But let's try to find a strategy for something called. Okay, it's not exactly finding a strategy. Let's see. Double chess. It's exactly like chess, except every player has to move twice in their turn. In the sense that, let's say I'm white, I can, let's say, maybe move a rook here, and then I can take my pawn ahead. So these counters, so like one move is just one normal move in chess, and in your turn, you are supposed to do two normal moves in normal chess. This is going to be double chess. And the question is, which player would you be if you want to win? Every time I ask you which player would you rather be, you are aiming to win because we are winners.
It can also be a draw.
Sure, it could also be a draw, but yeah, we don't know that yet. So okay, let's say you want to win, obvious. Okay. How many people there to raise your hand or give me a thumb? Are there any people who would volunteer to be? No, we won't be. Yes, I will repeat. I will repeat. Is it clear now? Is my voice clear now? Sorry about that.
Yes.
Yeah, okay.
Yeah,
Awesome. Okay, so just to quickly summarize, double chess is when you make two moves in your turn. You're supposed to make two normal chess moves. So, like one example would be you could move your knight and then you move your pawn. That's what you're supposed to do in a double chess move. And now the question is, which player would you rather be? Would you rather be, if you want to win, obviously, would you rather be the first player or the second player? So, and the question was, how many people, out of curiosity, and like we're not going to actually play double chess, that could go for quite a while. But how many people would want to be the second player? Just you raise your hand if you would want to be the second player. Or like give me a thumbs up or something. No way, you don't want to go second, you don't want to play as black. Okay. Yes, wants to go second. Right? That's why you raised your hand, right? Okay, no. What is happening?
Yeah, for the second one only.
Okay, you want to go second. Awesome. So what I'm going to do is, okay, let's say assume player 2 has a winning strategy. So there is something. Wait, I think Atharv has something to say about this. Do you, Atharv?
Yeah, you assume player 2 has a strategy, and then the first player puts the knight forward and then the knight back, which is a contradiction.
What is Atharv talking about, guys? Somebody explain. Somebody who's not Atharv explain. What did Atharv just say?
He's basically saying that he's switching the position. If black has a winning strategy, he's just switching the position, so black has the first move.
Exactly. So, I would like to quote Atharv on this. He is saying, strategy stealing, steal strategies, become evil. That is the way to win. So that's exactly what you do. Let's assume, for the sake of contradiction, that player 2 has a winning strategy. Then white can just do this.
But
White
black
can
also
just
do the same
yeah.
thing. But black can also do the same thing after.
Okay,
That's
true.
why
But then,
he has a strategy to ensure a draw or a victory. But
that will be a
can't lose.
perpetual draw.
But the game wouldn't stop or
Yeah.
start even.
Yeah, true. Can just take a knight forward and then and back again.
Can you tell me that how can one win in double chess in this game? Double chess.
Okay, so like we would have to add some more. We would have to add some more rules to this, I guess, about so that this actually makes sense. Otherwise, as people suggested, then this could just go on for an infinitely long time, and it would be a perpetual draw.
We can start like in the first move or the second move. We can like do this at any point in time, as long as we have a knight.
That is true. So does that mean that this game is a draw? Because if one of them has a winning strategy, then the other person has a winning strategy as well, which is a contradiction. So this game is going to end in a draw.
So
Yeah.
if one player tries to just move their knight forward and backward, then we can just scholars checkmate them.
I think we can try to force we can take the knights of the first person, something like that. We can try to take some moves. make a construction for it.
I think maybe it is a win for white or a draw.
Yeah. I think I'm convinced with the answer that it's going to be a draw because if one of the players has a winning strategy, the other player can just copy it and win, which is contradictory.
I even think that the normal chess is a draw.
Okay, I don't really have much to comment on that, unfortunately. I don't know, interesting. Okay. Hmm. Oh, okay. There's another very cool question about this. Okay, so the conclusion is so player two does not have a winning strategy, but this the same strategy player two can also apply, and then the game can just not go anywhere. So at least in this case, it's going to be a draw. But maybe some more questions to think about is can we make this, can we think of variations where we don't run into infinite loops? Something like you can't do the same move again or something of that sort. I don't know. Something to think about. Okay. Yeah. What was the question? Hang on, let me try to remember.
Why do we say it's a draw?
Wait, whose voice was that?
I am Devarchan.
Devarchan. Okay. It's a draw because currently, like, what we can just. So, our strategy is if player two has a winning strategy, then white can just take the knight forward and back again. And then, whatever black strategy is, white can copy that. But then, black can have the same strategy. As in, oh, now black is going to be the first person. And the game is going to be again black is going to be like white. So again, black can just take the knight forward and backward and whatever. So that's sort of like running into an infinite loop, which we can just conclude. So none of the players seem to be winning over there.
Oh, right, right.
So either it's going to be a draw or the player one is going to win.
But
Okay.
if
Yeah.
a player poses a threat of a checkmate, so the other player cannot just copyright. So if suppose I pose a threat of a checkmate, then he can't just copy me. Or if he just copies
Oh,
me,
not like that. No, not copying in that sense. So as a strategy is something that's previously been set. So so player B has an actual strategy where no matter what A does, player B is going to win. So if A does this, then player B is going to do this. If A does something else, player B is going to do this. Now we switch the players one and two because A goes knight forward, knight back. So now A is the player two, and whatever. So now A is player two, and whatever B's original strategy was, like if they do this, then we do this. So A follows that strategy. It's not like we can't just do something like
mirroring.
yeah. It's not exact mirroring. It's not like if you put the pawn forward, I will put my pawn forward. It's not that. It's that what would you do if I did the move you played? That was a long sentence. I hope it made sense.
Yeah.
Okay. Okay, so there's one thing suggested in chat, which is that we can make a rule that we can't copy just played moves, but we don't really know that because maybe a part of uh, the second player's strategy to win
Or
was
maybe
yeah,
maybe in the two moves
yeah.
you can't play the same piece twice.
That would be an interesting variation. Yeah. Okay. We'll think about this. I have another cool problem to discuss. We can take this up towards the end, maybe. What if there are limited number of moves? Yeah, but like, how do we ensure that there are limited number of moves? At any given point of time, even if both the players are just taking their, I was going to say horses, knights forward and back, at any given point of time, there are still going to be finite number of moves. So there's no way for us to ensure that there are going to be only limited number of modes. I'm not sure if that makes sense. Hopefully that makes sense. Anyways, let's take this up towards the end. I have another cool problem I want to talk about. So initially the numbers 1 to up till n are written on the board. And what we do at every time step is whoever's move it is. So in a turn consists of erasing a number along with all of its devices. Person who cannot make a move is a loser. Sorry, loses. What do we do? Who wins? Oh, interesting. So if you've solved this, then don't reveal anything. You can send it to me on the private chat if you want. Do people want to volunteer and play this game for demonstration, or do people want to straight away get into solving it somehow? I don't know. Okay, I guess people are working on their own. Okay, if at any point people have any ideas, just feel free to unmute and talk. Or in the meanwhile, we can also do a round. Do people want to play this? Any volunteers for playing?
I will play Ashutosh.
Awesome. Do you want to go first or second?
Second.
Okay. Does anybody want to go first? Somebody who's not Atharva or Moksha, preferably.
Can I go first?
Yes, Sahana. What will you remove?
Maybe I'll remove 4, 2, and 1.
Okay. 4, 2, and 1. Now?
I'll
Ashutosh,
remove
what do
5.
you? Okay.
Then I remove 3.
Amazing. Sahana wins. Player 1 wins over here. No, sorry. Yeah, player 1. Let's go again. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, guys, go again. Who wants to go first? Okay, people are thinking still. Okay. Okay, again, let's start with this. Since yes, you do get a redemption. Do you want to go first or second? Now we're solving 1 to 10.
First, maybe.
Sure. What do you want
Okay,
to?
I'll move 8,
Hmm.
4, 2, and 1.
Okay. Somebody volunteer to be a player too.
Can I be player 2 again? This time?
Yes, go on.
Or maybe 1 minute.
Sure.
I'll remove 7.
Okay. What do you want to remove, Ashutosh?
I'll remove 10 and 5.
Okay. Kahana?
I'll remove 6 and 3.
I'll remove 9.
Interesting. Again, it was player 1.
Oh, why couldn't you have removed 3? And then
Yeah, you can. I mean, wait, what?
yeah, and the last one is 369. 3 was the best thing to remove.
True. So when it was 369, best thing for Sahana to do would have been to remove 3. And then she would have won. So that would have been a player 2 win. So anyways, it is not really giving us much insight as to what is happening, I guess. So some people have already solved this. Again, since we've been talking about stealing strategies, that's a big hint. So assume player 2 has a strategy. Try to think about how you can steal the strategy. How can we steal it? Hehehehe. In the meanwhile, for other people who have solved this problem, 2 piles of stones. Can remove as many as you want from 1 pile, or remove same number from both. Find strategy. Okay. So let's say player 2 has a winning strategy. How can player 1 use that to their advantage? Remove 1. Excellent. So what you do is player 1 will just remove 1, and now whatever strategy player 2 originally had, you are now player 2. Now we have 2, 3, 5 up till n remaining, and player 1 is now player 2. So whatever was the strategy of player 2 earlier, you can just mirror it over here and win. That's a contradiction, because then player 1 wins. Still, remove 1. Patil. Win. Contradiction. Um, just just a disclaimer, you don't write like this in your RMO or InMo. You will probably just get a 0. But yeah, this is just for understanding purposes for now. I hope this made sense. Does this make sense? Yes, somebody's laughing on my jokes. Okay.
I didn't understand
Yeah, Sahana.
how does player 1 steal player 2 strategy here?
Okay, maybe somebody else can explain. Somebody volunteer to explain. Okay, fine. I'll give it another try. We have 1, 2, 3 up till n. So player 1 will just remove 1. And now, again, don't get, I think something that people get confused often is strategy does not mean something that you do this, then you do this, then you do this. Strategy means if the other player does this, then you do this. What does it mean when I say player 2 has a winning strategy? It means no matter what player 1 does, player 2 is going to always win. So let's say that player 2 strategy is something like, hey, first the A does something, then you just delete everything of, let's say, K. Then A does something, then because of that, you delete everything of, let's say, L, T, or something like that. Now, A can just remove just the 1, and now just think of B strategy. Now let's say B removes 5 and 1. Then A looks into B's strategy book. Acha, what is B strategy? What does B do if A removes 5? Then A does the same thing. And the game continues. Think about it for a while. I get it. It doesn't immediately make sense. But I hope it will make sense. Maybe. So this is again something that is not giving us an explicit strategy, but just a way to determine which player has the winning strategy. And there's no way player can have a winning strategy. Okay, for now this is okay. Hope this made a little bit more sense. Maybe did it make a little bit more sense, or are we still on the same?
No, it made a bit more sense.
Okay. So I would say maybe like think about it for a while later on, and if it still doesn't make sense, hit me up. We'll try to make it to make sense. Yeah. Okay. All right. Did I talk about the things I wanted to talk about? Symmetric ideas, stealing ideas, winning. Yeah. Start from the bottom and look at winning, losing. Okay. Amazing. So I think those are most of the ideas I wanted to discuss. We can solve a couple of cool problems now. So there are two things we can do. And one is either we can try a new problem altogether, or there was a problem I left earlier. I left you guys hanging about the Fibonacci. We can discuss ideas. What do you guys want to do? Raise your hand if you give me a thumbs up if you want to do the Fibonacci problem. Or give me what are the other reactions? Clap if you want to do a new problem. If you want to solve a new problem. Okay, 2 claps. Okay, 3, 4 claps. Bro, everybody's clapping. Oh my god. Okay. We can try this problem. Thibaut will be there in the P set, yes. Okay. So, what is the motivation behind this problem? It's basically if you have our original problem was to only remove stones from one pile, but over here, what's happening? So, the strategy that we had over there was to just keep equal number of stones in both the piles. Now, I'm just making that also. I'm making illegal. If you keep equal number of stones in both the piles, the other player can just gobble up both the piles in one. That was sort of the motivation behind thinking of this problem. So can we find a strategy for this? So do people have any ideas? How do people want to solve this? Let's group solve this. So how should we start?
Like I'm thinking about this, like suppose we have the 21 and 7 case only. So we remove not 14, we remove 13 coins from the first. So we have 8 and 7. Now whatever
Okay.
the player does, now we try to keep the difference 1 only. Maybe we can try like that.
Interesting.
Maybe we could
I
make
have another idea.
Maybe we could make a table with cells, and we label the cells from 0, like an XY axis, and then we rephrase the problem so that the first person to go to the origin wins, and you can take diagonal steps or horizontal or vertical steps down.
Okay, I like that idea slightly better. But yeah, does anybody have any counter? So, do people have any thoughts on this strategy? It's very similar to our original strategy, except we maintain the difference to be exactly 1.
We can remove 20, so it would be 1 and 7.
Yeah, okay. Also, like my answer to Ashutosh, no, I don't forget. I forget who proposed the strategy. Like I can mirror your strategy by making this 6, 7. Okay, if I make this 1, 7, is that what you're saying? That was another idea, right?
Yes.
Okay. Now I can just make it 1, 2, I guess. Now what will you do?
Oh, so this won't work.
Yeah. Even over here, if you make it 8, 7, I can remove 6 from both and make it 1, 2. And then I shall win again. Muahaha. I like Athar's idea though. That was probably how I would approach the problem as well. So if we have 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and so on. 0, 0. Is it winning for player 1 or winning for player 2?
The 0 and the 0 rows have all winning for player 1.
Yeah, this except this is winning for player 2. These are all winning. Oh, because the first player can't make a move because there's nothing to do. Does that make sense?
But if the first player can't make a move, then how can the second player make a move? Like after
No,
the
they
first, it
can't.
makes a move.
Yeah. So when it's 0 and 0, the first player can't make a move and it's their turn. So the first player loses.
Oh, okay, got it.
Okay. How about 1, 1?
Player 1
Player
wins,
1.
removing 1 and
All
1.
numbers are
Both
formed A,
piles.
A.
Amazing. Okay, these are all 1 as well. Fair enough. How about 1, 2?
You establish that it's losing. It's winning for 2.
Player 2.
Okay, what color should this be? No, this is already green. Okay, how about 1, 3?
That means all numbers 1, comma A for A
One.
and 2 is for player 1.
Yeah, we can just reduce it to the 1, 2 case.
And similarly, all in the diagonal of 2 going down.
Yes, true. We can remove equal number of things from both of them to reduce it to the 1, 2 case.
Can you check my solution once I've sent you on private?
Uh, yeah, I think that's the thing, yeah.
And then you repeat 2, comma 4 is winning for player 2.
2, 4 is running for player 2.
No, it's not. Wait, you still have to complete that lane. For
We
1.
can reduce it to 1, 2. So
Yeah,
Then 3,
but
comma 5 is winning for player 2.
true. And then all of these are gonna be 1. Okay, we need more things to the table, guys. This is also going to be 1. 7, 8. Wait, 5 के बाद 6 आता है. Sorry. 5, 6, 7, 8. 6, 7, 8. Okay. Yeah, these are all 1s as well. What's the next thing that's losing for you two?
I think 7, comma 4 is winning
Okay.
for 2.
Are we seeing any pattern?
n, 2 n minus 1. I think that's the pattern for this.
Wait, so 2 comma, this thing doesn't work though. 2
Can
comma
I tell the
3.
pattern?
Maybe n, comma 2 and minus 1 for all. No.
No, let's try this for one more. Just fine. Okay. What do you think is the next one going to be?
5, 9.
No, we can't have 5 comma 9 because
6,
3 comma 5
10.
is 3 comma 5 is done, right? So anything comma 5 we can reduce it to that case. Let me write
6,
things down actually.
10.
1 comma 2, then we had 3 comma 5, then we had 4 comma 7. Now what do we have?
It will be the first
6.
pair of
6,
integers so that
10.
those two integers did not appear before, and the difference of those two integers did not appear before in the differences.
Like the difference is increasing.
Right. That makes sense, right? Because if the difference is already there over here, then we can just remove equal number of things from both the piles to reduce it to this pile. And yeah, that makes sense. So that's why the difference is increasing. And how is the first number getting calculated?
Next one will be 813.
815, I guess.
No, it'll be
Is it-
813.
Yeah, I think it will be 813
Yes, 813.
because now the difference has to be 5.
And then 915.
Oh, yes, yes.
And then 16.
11 and what? Sorry, I'm so sorry.
Oh, then
17,
it's already done. Sorry.
12, comma something. 20? Yeah. And then so on and so forth. Although an interesting question to think about is there a function?
Closed form.
Is there a closed form for these?
But I don't think there would be.
I guess I can leave this hanging here as well. Question closed form.
Is there a closed form?
Is there a closed form? Yeah, I saw this question a while back. Actually, I don't remember I think there might have been one. I would also have to look into it. I think there is one, though. Maybe.
Maybe you write it as 1, 2, 3, 4, and then for each integer you write the pair next to it. Maybe you can try spotting a pattern from there.
That makes sense. Also, again, I'm seeing a bit more of Fibonacci here. I'm not sure if I'm hallucinating the Fibonacci numbers here or not, but 1, 2, 3, 5, 8, 13. And then my guess is that what's the next thing? 30, 21, 34 might also be one. That's my conjecture.
You can try continuing.
Yeah, I guess maybe I'll just officially end the class here so people want to leave. Thank you, people, for joining. This was really fun. I hope this was fun for you guys as well.
Thank you.